Last day that'll cover the quiz. Last day that'll cover the quiz, day 4. Let's take our angle proofs and make them one step longer. Great, it's a parallelogram. I'm giving you it's a parallelogram. Now look at my proof statement. Now I'm asking you to prove the sides are in the same ratio. Wait a second. We've been doing this a while, this unit. Sides aren't in a ratio unless I know what about the triangles. They're similar. So that's your first job right now. Before sides are in a ratio, I need to prove triangles similar. Darn it! I still have another issue. What triangles? Because look, you don't need to do a magic eye here. I see this triangle here. I see this one. I see this one. Pick 2 and hope I'm correct? No. Any ideas on how I can figure out which 2 I'm going to need to prove similar? Hi, Jonah.
Hi. You could look at the sides in the proof statement.
Look at the proofs. Give me one. Give me one side, Jonah.
CE.
Everyone, look at CE on your diagram. Is CE a side of one and only one triangle? Which triangle? CE, D. So you guys found the first triangle we're going to use. All right, give me another side from the proportion we're trying to prove. CE, what else is up there? BE. All right, everyone look at BE. Look at segment BE. Is that a side of one and only one triangle that you can see? Yeah, me too. Do we see the 2 triangles now you're going to prove similar? Guess what you're doing in your group? Get me the angles. Go. Get me the angles. I need angle. We know what triangles we need to prove similar. How do I get the angles equal?
Oh, actually, no, we need to say that BF is an extension of AB. Oh, wait, isn't AF is parallel versus C because BF is an extension of
So that's what I was thinking. Are DC and AD parallel? So why can't D and B
So you just say that, okay.
That's the better idea. Wait, so what did they
You would have
say?
gotten there, Keelan, but just 3 extra steps. You would have gotten those angles eventually, not called them alternate interior.
Extension of parallel lines of parallel. Yeah. So that's 4. That's step 4. So then step 3 is saying AB is DC. Parallel to DC. Because
Opposite sides parallel. And then we say BF is an extension for angle right here.
Of AB.
And then our next step
Of extensions of parallel lines of
and then we can say
Or you just say BF. Oh wait, ABF is parallel to wait, AF.
You say AF is parallel.
I think I did it wrong. Hold on.
Because
ABF
is parallel to DC. Extension of parallel lines. You have to say extensions of parallel lines are parallel. Then now we can say it.
Yeah.
So angle C is parallel to angle EBF because parallel lines imply alternate. Into
Okay, talk to me. Sorry, I took the easy way out. I got the verticals already. That's done. I didn't need to hear from somebody in here. Give me another pair and how you got there. Oh, 14. Take that as no. 24.
Angle C and angle FEE.
What about them?
They're equal
Why?
because DC and AB are parallel.
Okay, let's start there. DC parallel to AB. How'd you know that, Mahmood?
Because parallelogram implies opposite sides are parallel.
Nice. Little property from last unit. Yep. Keep talking to me.
And then AF is parallel to DC.
Thank you for putting that in. Hey, if you're going to tell me something about angle F here, or even angle EBF, that's outside of AB. So you just can't say DC and AB are parallel. You got to go the step further and say, hey, DC is also parallel to, make that a little longer, AF. And what was that reason, Mahmood? Good. Extensions of parallel lines are parallel. Now you can say your alternate interior. And there's two pair you may have used. What did you say, Mahmood? C?
I said C.
Okay. So angle C congruent to angle EBF. Or if you put in your proof angle F congruent to CDE, that's fine too. Same reason. Parallel lines imply alternate interior angles congruent. And now you have angle. Just please make sure when you write your similarity statement, one, it's in the right order, and two, you use the tilde and not the congruent symbol. Triangle DEC, similar to FEB. And here's our extra step today. It's very, no pun intended, similar to CPCTC. Because remember, when could we use CPCTC? After we prove triangles congruent. So after we prove triangles similar, we can now say, hey, now their sides are in proportion. So here's my proof statement. And here's our new reason. And you can write the abbreviation like CPCTC. Corresponding sides in similar triangles are proportional. I don't think it rolls off the tongue as nice as CPCTC, but it is what it is, CSSTP. And it's right above in the box too. Corresponding sides, similar triangles are proportional. Guys all good? Going? I'm not going to say much about this, and I'll let you go in your groups. The only thing you're uncomfortable about is that proof statement. Right? You're not comfortable about that proof statement. If you go back to the very beginning, day one notes on the very first page, you'll remember FC to DB is a way to write a ratio, and so is this as a fraction, FC over DB. They mean the same thing. Same ratios, just written differently. So if you don't like the way I wrote it in the proof statement, change it to the fractions you're used to. FC over DB equals AC over PB. You're going to have to do two things in your group. Number one, identify the triangles you need, because look at that diagram. We got a ton. So which two triangles do you need to prove similar? And then step two, go ahead and get after it. All right, go right ahead. And after a couple minutes, I'll put my version up on the board for you to check. But find the triangles first. Use your proof. Triangles were similar. Make sure you don't have a congruent symbol in between them. Make sure you said the right angles were congruent. I almost forgot that. Okay, say the right angles are congruent. How are we feeling, all right? We good with the proofs? And then yes, there's one more step to go. We can go with these that we're going to go tomorrow after CSSTP. What can we do? But let's worry about it tomorrow. because we need to do some more hardcore algebra. All righty, let's do it. AB parallel to CD. I did mention yesterday they gave us these these lines are parallel, makes corresponding angles congruent, and the triangle similar. In your group right now, here's what I want. You're not going to finish this. What I want is a good proportion set up, cross multiply, get it equal to 0, stop. And then I'll take over and we'll do the rest as a class. All right, set up a good proportion that matches up corresponding sides, cross multiply, set it equal to 0, and then let's stop. All right, let's stop. And then I'll take over after that. Some of you guys may have tried to factor that, but what's the problem? Can you find two numbers that multiply to -7 and add to -2? It's not happening. We'll be here forever. It's unfactorable. So that means to solve for x, if I can't factor, I'm going to go right to quadratic formula. I will give this to you on Thursday's quiz. No need to memorize it, but know how to use it. All right, so it's unfactorable. I have to use quadratic formula. No way around it. Before I start, I always like to identify what the A, the B, and the C values are before I plug them in. Hey, A value, 1. B, -2. And hey, C, -7. Let's do it. X equals, what are you plugging in right there where it says -B? My B is -2. So when I plug it in for -B, +2. Plus or minus. You're not doing a darn thing on your own. You're letting the calculator do what the number underneath the radical. Grab the calc. Let's review again from day 1. A value is 1. 1. Store right to the left of your 1. A, alpha math. What's your B value? -2? -2. Store in for B. Got it. -7. Store in for C. And now let the calculator do the work. What's the value of B squared minus 4AC? And what number am I going to put under this radical? 32. You will never get it wrong. Unless you type in something wrong, I guess. But could you do it on your own and get 32? Probably. But you're playing with fire. All right, you're playing with fire. If you're going to try to do that on your own, I would rather let the calculator do the work for me. So 32 underneath the radical all over. What's in the denominator? 2 times my A value. So in the denominator, 2. Okay, let me ask you a quick question. I want you to look at the entire problem right now that we're doing. When we got to this point right here, anybody know why, without even looking, I knew I wasn't going to be able to factor this when I got to this point? Look at the total problem right now. Look at everything that's involved with this problem. Anybody gonna know, even before I started the problem, let's put it that way. Even before I started this problem, I knew I wasn't going to be able to factor when it got to this point. Anybody see anything on the problem that said, you're probably not going to be able to factor this one? Hi, Avery.
It says simplest radical form.
Look in the directions. Excellent. Look in the directions. Simplest radical form. Hey, have you ever had radicals when you've tried to factor? Yeah, me neither. So if you see this, leave your answer in simplest radical form. They are telling you right now, no shot at factoring. You're going to have to use quadratic formula. All right, so just be alert for the directions. Speaking of simplest radical form, go ahead, break it down, 32. Talk it over in your group. Make sure you hit the biggest one. 4 does go into 32, but it's not the biggest. Come on, keep going. Come on. Break it down and replace it. All right, are we breaking it down into 16 and 2? And we're replacing radical 32 with 4 radical 2. All right, so let's replace it. 2 plus or minus 4 radical 2 over 2. Not simplified, though. The radical is, but not the fraction. Here was my concern day 1 and day 2 when we did this. Everyone sees the 2 on the bottom. You need to divide both sides of the plus or minus by that. Go ahead. 2 divided by 2? 1, but the 2 doesn't disappear. 2 doesn't disappear. You got to also divide the other side by 2. So on the other side, I'm going to get plus or, I don't know what's happening there. There we go. Plus or minus, what am I going to get on the right side now? 2. Can you divide the radical? This was this was controversial today. Can you divide the radical 2 into 2? No. One's underneath the radical and the other's not. Can't do it. So it's just 2, 1 plus or minus 2 radical 2. Unfortunately, that's not right. Unfortunately. It's sad. We did everything correct too. We did, but it's not right. Here's why. And this is why it gets a little tougher now. I wrote 1 plus or minus 2 radical 2. How many answers is that right now? How many answers do I have up here? You sure?
2.
I have the plus or minus, I have 2 answers. I have 2. Here you go. What are my 2 answers? If I wrote them out individually, what are my 2 answers? 1 plus 2 radical 2. And what's my other answer if I wrote it out individually? 1 minus 2 radical 2. Can you grab your calculator real quick? And I will too. Can you do 1 minus 2 radical 2 to see what this answer actually looks like? 1 minus 2 radical 2. Do you see what I'm talking about now? Why my answer's not right? Look at that number right now on your calculator. Look at that number. And why is that number going to be an issue on, say, side FA? If that's what x, look at your calculator. If that's what x is equal to, and I plug that in and go minus 1, what's the issue with FA now? It's negative. We can't have that. So even with quadratic formula, I may probably have to reject an answer. All right? I may have to reject an answer, which happens here. This version gives me a negative side, so it's gone. So I'm only left with 1 plus 2 radical 2. All right, so even with quadratic formula, you might have to reject an answer. All right, just flip it over. It's homework time, but flip it over. So we don't get nervous, to take a look at the directions for number 1. Not simplest radical form, but nearest 10th. That's okay, look. Still do what we did. Then go to your calculator. All right, 1 plus 2 radical 2. See what it is? Round it to the nearest 10th. That's what I'm looking for. So don't think you got to do anything different. Still use quadratic formula. Still break it down. But at the end, plug it into your calculator. Maybe you'll have to reject one. If not, make sure you round it to the nearest 10th. On you guys. Go ahead. The rest of the time is yours.